Good morning, and let's look at using the Pythagorean Theorem. So, yesterday in class, we were learning all about the Pythagorean Theorem this week. And Pythagoras was an ancient Greek mathematician and philosopher. And remember that the Pythagorean Theorem deals with just right triangles. And to use the Pythagorean Theorem, we watched the water demo and we learned that if you were to take every side of a right triangle and you were to make a square off of it, and we're going to try to make this the same length as we can because it has to be a square. It does not work with anything other than a square. But if you were to take a square and you were to make a square off of the side of each one of these legs of the triangle, then the area of this square, which is 36 because 6 times 6 is 36, and the area of this square, which is 64 because 8 times 8 is 64, would equal the area of the biggest square. And we remember we call the longest side of every right triangle the hypotenuse, which is a special fancy word for the longest side. We might look at the word hypo in there, which tells us that it's very long. And so a squared, here's my a side, a for altitude or height. B squared, which is B for base, is equal to the C squared, the C being the hypotenuse. And you'll notice that this 6 squared, well, that meant 6 times 6. That's where we got this 36 from. And then we have over here this 8 squared. That's 8 times 8. That's what gives us this 64. That's where that came from. And we know it's going to equal the whole area of this square. So when I add those together, 64 plus 100, that actually is equal, 64 plus 36, that's actually equal to 100. So I know the area of this big old square is 100 centimeters squared. Well, that leaves us with, well, what's the side length that would multiply by itself to get the 100? And we know that 10 times 10 is 100. And so we take the square root of 100, square root of c squared. That gets rid of the square because the opposite of a square is a root, just like the opposite of add is subtract and the opposite of multiply is divide. The opposite of a square is a square root. And so we're going to take the square root of 100, which gives us 10. And that just means that 10 times 10 is what gives us this 100. And so if this side is 6 and this side is 8, then this side must be 10. I'm going to go ahead and clear that. We're going to do a few more examples because today you're going to be practicing this on your homework and on your quizzes like we did in class yesterday. Now, this is one that we did yesterday. So let's do one that we haven't done yet. So here's a word problem. It says Billy's building a slide for his kids. The ladder is 3 meters tall. Well, you can see that they've marked the tall ladder of that slide as 3 meters, and the slide is 5 meters long. So this side of it is 5 meters, and they've marked that right here for us on our picture. What's the distance between the ladder and the bottom of the slide? So the first thing that we want to do is we want to go find the triangle. I found it. Did you? Here it is. Here's our right triangle. And remember, the Pythagorean theorem only works with right triangles. And then we're going to label our sides. Now, they were very helpful. They labeled the B. Honestly, it doesn't matter which one's the A and the B, as long as you can find the C, and that's what we practiced in class. As long as you can find the C, you know what to do. We know that the C is the longest side, so I'm going to go ahead and mark this side with the C. We know the 5 is a C, and so I can go ahead and even write C equals 5. B is the base. We don't know the base, so I'm going to write B is equal to, I don't know. And then obviously if this is the B and this is the C, this is the A. So our A is equal to 3 meters. And we'll just remember that we are doing everything in meters. So the first thing we want to do is we want to write our formula. A squared plus B squared is equal to C squared. And I like to personally draw a little picture of it and label my squares on there so that I don't forget what to do. I know this is 5. I know that this is the one I don't know, and I do know that this is 3. And I want to remember to put my information in here. So 5 goes with the C. I know that the A goes with the 3. Don't forget your squared. And then we're going to be solving for B. So I'm going to write plus B squared equals. So the reason that I write this is to help me remember that I have to square it. 3 times 3 is 9. That's where this number comes from right here. 3 times 3 is 9. And I know that 5 times 5 is 25. So I'm going to go ahead and put my 25 in there because I want to make sure that I'm remembering to square it. So I have to put my 25 in there. And then I know that B squared. Well, I'm thinking to myself, well, what plus 9 is equal to 25? 9 plus something is equal to 25. Well, 10 plus 15 is equal to 25. So that must be 9 plus 16 is equal to 25. If I wasn't sure of that, of course, I can use opposite operations. If I'm adding 9 to get the 25, I subtract the 9 away to get that b squared is equal to the 16. Then I just have to think to myself, well, this is 16. This square is 16. So what's the side length of that square? See if you can figure it out. I hope you took the square root of both of those and remembered that 4 times 4 is equal to 16. And so it's 4 away. Now this was meters and this was meters, so it's equal to 4 meters away from the bottom of the slide. Let's do one more example on this video, and then we'll call it a day, and you can work on your practice problems yourself. So we've already done a 6, 8, 12. So this is something a lot like what we did yesterday. We had this building. It was on fire. Remember, actually, this picture is better than the picture I drew in class. They're better artists than I am, for sure. And we have a 15-foot ladder leaning against the side of the building. So first of all, I know this ladder is 15 feet long. And then it says that the building is 12 feet high. So I know that this height right here is 12 feet. And it says, well, how far away should they place this ladder? Where should they put the ladder to get that 12-foot high? They don't want to go too high. They don't want the ladder to be up here. They don't want to go too low. They don't want the ladder to be down here. So how far away should they place it to make sure that it goes directly to that window where somebody's at? And so we're going to find this value. Now, again, I like to draw just a little thing just to keep track of it. I know my 15 was here, and I'm going to draw my little square off the side of it. I know my 12 was going up the side, so I'm going to draw my square off the 12, and I'm going to draw a little square here. So I'm thinking to myself, well, first of all, I know that the 15 is the longest side, so I know it cannot be more than 15. I'm going to make sure cannot be more than 15. Do not allow it to be more than 15 because the ladder is 15 feet. So I know that it can't go higher than 15 feet up the wall. So that's my first thing. If I were to do it wrong, I would get a number that's more than 15. If I get a number that's more than 15, I'm going to think, oh, wait, I must have done something wrong. So we're going to label our sides. A for altitude, B for base, C for hypotenuse. The longest side is my ladder. It's the longest thing in this problem. And so I'm going to write A squared plus B squared is equal to C squared. And I'm going to substitute the values that I know into my equation. 15 is my C, so I'm going to put 15 squared under the C. 12 is my A, so I'm going to put 12 squared under my A. B is the number I don't know, or the distance. I can write D squared or B squared. I'm going to personally just write B squared. And I'm going to figure out the information that I have in here. Well, it says 12 squared. That's 144. Looking at my little drawing up here, I know that the area of that square is 144. This is 15 times 15. So this big square is 225. And if you remember from the water demo, these two are going to add to equal the 225. So I know that for some reason, I'm going to have to subtract to figure out what it is. That's because if they add to equal the 225, then I can subtract to get it back. So I'm going to take the 144 away from both sides and see what I add to 144 to equal 225. So B squared is equal to, that's a 1. I'm going to borrow, and I'm going to get 81. Well, I know that the area of this square is 81. I'm not done because I know I'm looking for a number that's smaller than 15. What times what is equal to 81? I hope you took the square root and you remembered that 9 times 9 is equal to 81, and I can put my 9 in here. This is 9 feet away, and that makes a lot of sense to me. 9 feet, 12 feet, 15 feet, they do seem to work together. So it is 9 feet away. All right. There are some times when you're going to get a problem with the Pythagorean theorem where it's not going to come out even. And so for some of these, you might not end up with a number that's perfectly straight or that doesn't come out perfectly. So one of those ones that we did yesterday, I know it says to come up with your own problem here, but I want to just give you an example. If I were to have a triangle, let's say that these were even, this is 10 and 10, and I'm looking for this. So I have like this square that's 10 by 10, and I'm trying to figure out the distance across that. So I have this. So I'm going to label A, B, and C. Remember, A and B always make the right triangle, and C is across from it. It's the hypotenuse. If I have something like this, and I'm going to try to figure out what C is, and I substitute in my tens, and I get 10 times 10 is 100, and 10 times 10 is 100, and that's equal to C squared. Well, 100 plus 100 is 200. And so when I figure out that that's C squared, I'm thinking, wait a second. 10 times 10 is 100. 11 squared is 121. 12 squared is 144. I'm getting closer to 200. 13 squared is 169. 14 squared is 196. 15 squared is 225. Uh-oh. Do you notice that 200 is somewhere between 14 and 15? That's one of those irrational square roots. So I know it's a number that's 14 and a little bit more. If I want to, I can leave this in square root form, and I can just get that C is equal to the square root of 200. I can leave it like that. That is fine. Or I can use my calculator, and we're going to go ahead and go on Desmos to figure out what the actual square root of 200 is. Remember, we're going to get an estimated square root because it's an irrational number, but I know it's 14 point something. And I'm going to get out of here. I'm going to go to my Desmos calculator. Oops, see if I can spell it correctly. Desmos Scientific Calculator. And I'm going to find the square root of 200. I'm looking for something that's 14. Oh, look at that. It's approximately 14.14. It's not exactly equal to that. This is going to go on forever and ever without stop, but that's just a good idea of, and a good estimate of the square root of 200. So if I were to solve a problem, just like I was saying, where I had 10 squared plus 10 squared is equal to C squared, and I got 200 is equal to C squared, and I went and took the square root of that, then I can write C is equal to the square root of 200, or C is approximately equal to 14 and 1400ths. Now it's not equal. I'm cutting it off. I'm truncating that value, but these are okay answers. This one is exact. This is an estimate, which is why we change our equal sign to approximately equal to show that it's not exactly equal to 14 and 1400ths. I hope this little tutorial helped. If you've been in class, you've done it with me, use your notes, and I want you to finish your worksheet today, and I also want you to go in and do that quizzes. Have a fantastic day. I'll see you tomorrow.